Guys, what was the last thing? I think we got to this question, right? All right. So in the previous lesson, guys, we solved if the reactant was only one reactant. What if we have two reactants? So this time, you cannot say that you can choose any experiment that you want. And this time, it's not correct. So look at this part. Again, find rate law, you have to find the order. But we have two reactants this time. Guys, pay attention to this part very carefully. If we have two reactants, in that case, when you choose the experiments, you have to pay attention to this part. For example, if you want to find the effect of A on rate, then effect of B separately on rate. What do you have to do? For example, in A, if we look at the change of A, is 2.4 to 7.2. It's changed, or from second to the third. But if you choose second and third for A, if you choose second and third, but in the second and third, B is also changed, then the rate which is changed between the second and the third, is it changed because of A or just because of B? Because of both of them. So in that case, we don't know which one has the most effect on rate. So in order to do that, what do we have to do? If you want to find effect of A, the B must be constant. If you want to find effect of B, A must be constant. Okay, A must be constant. So for calculating, for order, or to find order of A, you have to choose experiment 1 and 3. Why? Because B is constant. So guys, if I choose 1 and 3, if I compare 1 and 3 for the A, as you can see, B is constant. What does that tell you? The rate that is changed between 1 and 3, the rate is changed. We are sure now that the rate is changed because of A. The rate is changed because of A. Okay, because of A. Now, how do you compare? First, you will say concentration of A in the third one over concentration of A in the first one. Why the third is on top? Concentration of the third is more than the first. So put the higher concentration on top, the lower concentration in the bottom. So in the third one, it's 7.2 over 2.4. In this case, it will be, the result is 3. So it means that when we change the concentration by 3 times, what has happened to the rate? So the rate has changed from third to first, from 5.4 times 10 to the power of negative 8 over 6 times 10 to the power of negative 9. So in this case, it will be 9. Again, it means that when we changed the concentration of A by 3 times, what has happened to the rate? It has been increased by 9 times. So in that case, you can say concentration is changed by 3 times. Rate is changed by 9 times. So what would be the power of the order? So 2. 2. And it's 2. That's order of A. Okay, that's order of A. Now, let's find the order of B. So for A, we chose 1 and 3. So what do we have to choose for B? We have to choose for, let me solve it here. For B, choose 1 and 2. Why? Because in 1 and 2, the concentration is changed for B, but for A is constant. So we have to choose 1 and 2. You know why? Because A is constant. Now, in this case, concentration of B, in the first one over concentration of B in the second one. This time, why did I put the 1 above that? Because concentration of B in the first one it's higher. So 4.8 over 2.4 is equal to 2. Now, we learned that concentration has been doubled. Then when the concentration is doubled for B, what has happened to the rate? Again, rate of the first one over rate of the second one, which is, in the first one, 6 times 10 to the power of negative 9 over 3 times 10 to the power of negative 9, it's equal to 2. Then 2 to the power of what number? Which number is equal to 2? Then m must be 1. That's order of B. Okay, that's order of B. Now, you have order of A. You have order of B. Now let's find K. Okay, let's find K. K is equal to, if you remember in the previous lesson, we said, if you want to find K, for the value of K, you can choose any experiment that you want. You can choose the first one, second one, and third one. But for this question, I recommend that you choose the second one. Why? Because it is the same concentration. This makes it to be easier to calculate. Why? K is equal to R over concentration of A squared, concentration of B. So if they are the same number, you can just merge them together and have power of 3, just for easier calculation. You can, but still, you can choose any other experiment that you want. So in the, let's say we choose experiment 2. Rate in the experiment 2 is 3 times 10 to the power of negative 9 over 2.4 square 2.4 to the power of 1. Guys, you can write in your calculator 2.4 to the power of 3, because this is square and this is 1 together, total to the power of 3. So the answer is 2.17 times 10 to the power of negative 10, 10 power negative 10. And what's the unit? Total order is 3. 2 for the A, 1 for the B. So total order is 3. So the unit will be 1 over m squared times s, or m to Guys, we have this question. Actually, the solving of this question is really easy. But the problem is the way the question is explained. This section, especially when you do the calculations and the solving of this section, the answers are really easy. Solving is really easy, as long as you understand the question. If you just understand the question, what is asking, what is given, the rest is easy. Okay, the rest is easy. For example, in here, if you look at this question, pay attention to how the question is phrased. It's very important to understand this question. Look, the rate of a hypothetical reaction involving L and M is found to double when the concentration of L is doubled. Okay? What is given in here? It has given you an information, but I have to understand the information. When it says hypothetical reaction involving L and M, it's actually just an explanation that you have a reaction, the reactants are L and M, that's it. So you can put 2 commas in here. Next it says is found to double. Guys, what does it mean? Or what is it talking about when it says it's found double? What is it talking about? The rate. So it means that the rate is doubled, is found to double, okay? This part here is just an explanation that the reaction is L and M, that's it. But it's giving the information about the rate. So rate is found to double. Is rate to find when? Why did it double? Because we have changed a reactant concentration. How? It says when the concentration of L is doubled. So let's write this in a more easy way. It's saying that concentration of L, when it is doubled, rate also double. So if we double something and the rate is also double, what is the power? Let's say x. What is the order? What is the power of L? It's 1. So it's 1 is order of L. Then let's go to the next part of that question. It says, and to increase fourfold. So quadrupled. So 4 times. What is increase 4 times?
Concentration.
No. The rate, again, is going back to the rate. That's why I said like this question is kind of tricky. The phrasing, the explanation is a little bit confusing. So to increase fourfold, it means that the rate has increased fourfold. The rate has increased fourfold. When? When we change the m, when we increase the m by 2, when m is doubled. So it means that m, when m is doubled, rate quadrupled, increased by 4 times, fourfold, so rate quadruples. So in this case, you will say when the concentration of m is doubled, rate is increased by 4. So what is the power? You can just write y. So y is the order of m, which is 2. That's order of m. Then in this case, we can say that rate law is equal to k times concentration of L. Where's that? Sparky. All right. So concentration of L to the power of 1, concentration of m squared. That's the rate law. Okay, that's all we have to write. And the next question is easy, so I'm going to make it a homework. Guys, we have rate laws and reaction pathway. What is that? So we have at the beginning of the chapter, we had steps of reaction. We had steps of the reaction. Can you guys please close that window? Too much noise. Perfect. All right, guys. Again, in this subject, we have rate law and reaction pathway. So in the beginning of the chapter 5, we said that some reactions occur in multiple steps. 2 steps, 3 steps. Now, we are talking about those kind of reaction which they have a certain mechanism, which they have steps and the relation to rate or rate law, okay? Now, most reaction when they have 2 steps, one of them is slow, the other one is fast, okay? So if you remember at the beginning we said some of the reaction are 2 steps. So one of them is slow, the other one is fast. What do we call the fast reaction? What do you call the slow step? We call it rate determining step. We call the slow step rate determining step. Let's stop here. Why? We say that rate determining step is the slow step. Because the important part is the slow step. How? Let's say we have a reaction. The reaction takes in total 60 seconds. The slow step takes 59. The fast step only takes 1 second. Now, if you want to make that reaction faster, if you want to see the effect on the rate of that reaction, are we going to change the slow step, or the slow step is important or the fast step? Of course, the slow. Why? Because the slow step, if you make it twice fast, let's say from 59 seconds, it will become like 29 seconds. So that's twice as fast. But in the fast step is 1 second. If you change it to twice the speed, it's only 0.5 seconds. There is not much change. So something that is in the fast step is not that important. What is important for us? The slow step is important for us. The slow step is important for us. Now, we have another note, which we are going to use it a lot if we have slow step and fast step. From now on, from now on, you can take coefficients of reactant of slow as the order of that substance. If you remember in the previous lesson, we didn't take coefficient as order, right? We said coefficient and order different. But this time we say coefficient of slow is order. So if you have the coefficient of the slow, you can find the order of the reactants. For what? For the slow step, not for the fast, not for the net, only for slow. You do not look at fast, you do not look at the net, only slow step. Now, if two steps are given, how do we know the steps are slow step and fast step? This note is really important. Most of our questions regarding this subject, you have to know this, then you can solve it. If you don't know this, if you make a mistake in this, the question is wrong. The question is wrong. So for example, it says here, intermediate substance is formed in slow. So you will recognize it by intermediate. What is the intermediate? A substance that appears in the steps, but not in the net. It's not in the net. So it means that if you see something intermediate in the product, so intermediate is product of slow. When it says used up in fast step, it means that it's in the reactant of fast. Guys, this is so basic, this is very important. So if you recognize the intermediate, it's not in the reactant side, or it's in the product side, it means that this is the slow step. If it's in the reactant side, it means that that step is the fast step, which we are going to solve questions right after this, okay? Now, some reactions, we don't have slow and fast. In some reaction, we don't have slow and fast. It's one-step mechanism, single-step mechanism, okay? Like they have asked 3-4 times regarding this note for a single-step mechanism. Single step means it's just one step. It doesn't have slow, it doesn't have fast, only one step, okay? It says you can take the stoichiometric coefficient as order, just like the slow step. The keyword is one-step mechanism or single step. That's the keyword. What do we mean by this? Guys, if after this, the question says we have a reaction, it's one step, so no slow, no fast, and no data, no information is given. Look at the previous examples. The reaction is one step, but we found order by using the data, right? What if there is no data? What if nothing is given? Vice versa, actually, it's asking about the data. Okay, it's asking about the data. So in that case, what are you going to use? The coefficients. So here's the point. If we have a one-step mechanism and no data is not given, you have to use coefficient as orders. Other coefficients are used as order if no data is given. We're going to solve a couple of questions also for that note. But before that, let's focus on this part. Now, before starting solving question, let's start with a couple of examples. I'm going to explain the whole thing again, okay? For example, we have this reaction. From now on, if it says the reaction, this reaction, in the following reaction, it's talking about the net. It's talking about the net reaction, okay? This reaction, it has two steps, slow and fast. Slow and fast, okay? Now, in the slow is given, the fast is also given. We have the net, but what if we don't have the net? How can you make the slow and the fast give you the net? What do? Just add them together. Just add them together. How? You will cancel anything that's in the reactant of something and in the product of the next one. For example, NO2 is in here. Another NO2 is in the product. So cancel these two NO2s. Now, what else do we have here? NO3. That's it, done. Now write the net. What is left behind? In the reactant, we have NO2 left, one NO2, and CO is left. So write NO2 plus CO. Then, what is left in the product? NO and CO2. That's the net. As you can see, they are the same. Okay. Again, let's repeat the previous notes. Which one is the rate determining step? The slow step. Again, if it asks which one is the rate determining step, is the slow step. Next, we said if it's rate determining step, from now on, we will use the slow step to find rate law. So where do you take rate law? From the reactants of the slow. What about the order? Where do you take the orders? From the coefficients of the slow. From the coefficients of the slow, okay? Now, don't look at the net. Again, I'm going to repeat that. Don't look at the net. Only pay attention to the slow for finding rate law. Slow is the one that decides how fast the reaction occurs. Okay? Now, R is equal to K. Concentration of the reactant. Which reactant? Of the slow. Which is NO2. Only NO2. How many NO2 do we have? It means that the coefficient is 2. So, you'll write the 2. So, this 2 comes from coefficient of slow. It comes from coefficient of slow. 1 and 2, both of them are NO2, so the power is 2. Now, the next part, what is the intermediate? As you can see, NO3 is not in the net. NO3 is not in the net. It means that NO3 is intermediate. And look at the note that we said. Intermediate is in the product of the slow. Intermediate is in the reactant of the fast. So it appears in some steps, but not in the net. But not in the net, okay? That's intermediate. So if the steps are given, you'll find net, just add them together. That's first. What if, same reaction. What if the net is given and we have to find the fast step? What if the net is given, we have to find the fast step? You can do it in two ways. I will give you another way, another method that's easier than the minus, okay? But first, this is the first way. The second way is the easy one, okay? But first, let me explain this part, okay? Then I will give you the easier way. I will give you the easier way. First of all, guys, pay attention. What do we have here? NO2. How many NO2? 1. Well, in the reactant of the slow, we have 2. Why? Why out of the 2 NO2, only one of them is here? It means that one of them is cancelled. That's how you think of it. That's the logic of it. If we cancel NO2, where should be the other NO2? So it must be here. Guys, please sit straight. Now, that's the NO2, okay? That's the NO2. One of them is cancelled, that's why we only have 1. Then, CO. Did this CO come from the slow? No. So if it's not from the slow, where did it come from? It must have come from the fast. Then, let's compare this part and this part. We have NO3 in the slow, but it's not in the net. Why? It's cancelled. Since NO3 is not in the net, then NO3. That's how you think when the question is given. Oh, NO3 is not in the net. Then NO3 is the intermediate, directly. If something is not in the net, it's directly intermediate. So, intermediate is in the product of slow, but in the reactant of fast. So, I'm going to write NO3 here. See? NO3 is not in the net. So, it is definitely cancelled. And intermediate, since it's intermediate, it must be in the product of slow, but in the reactant of fast. Then, what do you have here? NO. Where did this NO come from? from the slow. So it's done, nothing else. Then we have CO2. Did the CO2 come from the slow? No. So it must have come from the fast. Then that's the fast step. Compared to this one, NO3, CO, NO2, and CO2. Okay? Then how can we make this one easier? Again, same question. I'm going to say, if one step is given, it doesn't matter whether it's slow or fast. It doesn't matter, okay? If the fast is given, if the slow is given, same logic, same solving. Now, which step is given in here? Slow step is given. I'm going to say, reverse the given step. Which one is given? Slow. Reverse it. Okay, we're going to reverse it. So, NO plus NO3 becomes NO2 plus NO2. So this one is slow reversed. So this is the second way that we don't need the subtraction. This is the easier way. Okay? Guys, this is gonna help you a lot. This is gonna help you a lot. This is so easy. Just reverse the slow and it says added with the net. In this way, you don't have to think and you're not gonna get confused how you're gonna solve it. Just do this and the rest is just easy. Okay? Now when you write the net, don't reverse the net. Just keep the net like as it is. So NO2 plus CO becomes NO and CO2. What do? Cancel everything that in the product on the reactant, NO and NO. That's it. What is left? NO3 is left. CO is left. NO2 is left. Plus CO2. We got the fast. This way is very, very easy. I know the subtraction way, a lot of students make that mistakes when they have the subtraction way. But in this way, without any thinking, you'll not make any mistakes. Okay? We're going to solve more questions using this part. Do you have any questions, guys? Something that you haven't understood? Yes? Yeah.
Here, since there's no CO2 over here, shouldn't it be like over here?
It's CO2.
Yes.
CO comes from here. So the CO2, where is the CO2? Where did it come from? Product.
Yes.
Is it possible that it comes from the reactant? No. What about this question? It says we have two steps, slow and fast. Both of them are given. Both of them has been told that it's slow and fast. Now, identify the rate determining step. Identify the rate determining step. So let's put this one as A, B, C, D, and E. Okay? Now, identify the rate determining step. What is the rate determining step? Slow step. Okay? B. What is the intermediate? Something that can be cancelled, and that is just F. Okay? F is intermediate. C. Write the reaction rate law. Where do we take the rate law? From net or slow? From the slow. Always from the slow. Always. So R is equal to K times. What do we have as a reactant of slow? 1 NO2. So it means that the concentration of NO2 to the power of 1. Okay? To the power of 1 times concentration of F2.
حسين محمد منتصر مريم دقل يوسف خميس أمانة نعرف عمرهم
يعني أصلا غيابين؟
يعني منال
all right. Now, so again, rate is equal to K. Concentration of NO2. How many NO2 do we have? 1. How many F2 do we have? Only 1. Okay, only 1. It's 1. You don't look at the net. No, just look at the slope. I know you are looking at the net, but we don't need the net. We only need the slope. You have to take it from the slow one.
Only the steps, right?
Yes. Now, D says net. We have to find the net. So the F are cancelled. It means that we have 2NO2 plus F2 becomes 2NO2F. That's the net. And E says, what's the total order? Total order, one of them is this, the other one is also 1. So 1 plus 1, that's the total order. Okay, that's the total order.
Can you return it to the last one?
Yes. Yes. Now, guys, let's solve this question. Let's solve this question. It says reaction rate law for this gas reaction. So again, when it says this gas reaction, it means that that's the net. Okay, that's the net. Okay, let's say what's given. What's given? In this type of questions, we are going to use all the notes and explanation that we have learned before. The net is given, but this time, the slow and the fast, none of them are given. You have to find those steps from the informations given. It says, this reaction is the net, and the rate law is this one. So, this rate law must have come from the, which step, slow or fast? From the slow. So this indicates reactance of slow, okay? This indicates the reactant of slow. Now, intermediate is also given, N. First, if you want to solve it like more easily, first let's bring the slow. Let's write the slow. It says the slow has 2NO in the reactant. So 2NO, that's the slow. Guys, when it says reactant of slow is 2NO, it's just 2NO. From now on, after this, you cannot do anything about it. You cannot balance it. You cannot add anything. This is it. Done. Because if it was anything else, it would have been written in the law, okay? It's just that. It's just 2NO. Now, what about the product? How do I know what is the product? First, what is given? Intermediate. Intermediate is in the product of slow. So I'm going to write just N. Is it done, the reaction? No. Something is missing. It's not balancing, and it's not balanced. You cannot touch the N as well, because just N. No. You have to add something from the product of the net. Guys, pay attention again. Pay attention to this one. How do I know the product of this part? So it's either, since there's nothing else, so it's either N2O or NO2. How do we know which one? Is it N2O or NO2? Why? By the balancing. Exactly. I'm going to write this in an incorrect way, okay? Don't write this part. Let's say I tested NO2. Let's balance it. We have 2NO. We have 3N. 2N, 3N. We have 2 oxygen. There is only 1 oxygen. So this is wrong. Let me clean this one. Now, what if I add the next one, NO2? NO2. Now, 2N, that's 2N. 2 oxygen, that's also 2 oxygen. That's also 2 oxygen. Now, we got the slow. That's it. In order to find the fast, because it says suggest a reaction mechanism. So write all the steps, okay? What do we do?
So the N is in reactance for fast step?
Yes, but not only N, you have to find everything else. What do you do? Slow is reversed. Reverse the slow step that's we have found. Then NO2 plus N becomes 2NO. Added with the net, added with the net. Where's the line? Now, what is the net? 3NO becomes N2O becomes N2O with what? With NO2. Now, let's just cancel out. NO2, NO2 has cancelled. NO, NO, one of them is left behind. Okay, sorry, not that one. One of them is left behind. Then we're going to write the fast. We have N. We have one NO and N2O. That's the fast step. Okay, that's the fast step. All you have to do is just, when you found the slope, just reverse the slope and add it with the net. Okay, add it with the net.
So we can check if it's correct.
Guys, now let's solve this question. Let's solve this question. It says the slow step of NO2 CO becomes NO and CO2. Guys, doesn't mean that this is slow. It says slow step of. So this is the net. Okay? All right, what about slow step? And it's giving me an information about the slow step. Consists of collision of two NO2. So in the slow step, we have two NO2. That's it. Reactant of slow, we have two NO2. So let's just write slow, 2NO2. That's it. Then, intermediate is NO3. I'm going to write NO3 here. I'm going to write NO3 here. Now, is it done? No. So look at the net. One of these must have come from the slope. Must be from the slope. So do you think that the CO2 will come from the slope? No, because there is no carbon here. What about NO? If I write NO, is it going to be balanced? Yes. 2N, 4 oxygen, 3 and 1, 4 oxygen, balanced. That's it. It's suggesting, says, reaction mechanism. Reaction mechanism means find the fast and the slow. We found the slow, let's find the fast, okay? What did we do? Slow, reverse. So it becomes NO3 plus NO becomes 2NO2, okay? Now, add it with the net. Add it with the net. What is the net? It's NO2 plus CO becomes NO plus CO2. Now, add them together. Add them together. So NO and NO are cancelled. NO2 and NO2, one of them is left, and that's it. And the result is NO3, you will get the fast NO3 plus CO becomes NO2 plus CO2. And that's the fast step. Of course. So the slow step says the slow step of this reaction consists of what? Collision of two NO2. So it must be, the reactant must be 2NO2. That's one. Intermediate is NO3. Where is intermediate? In the product of slow. So we wrote it in the product of slow. Then something else must come from this slow. We have to finish the slow. Look at the net always. When you need to finish the product of the slow, look at the net. Is it CO2 that's here, or is it NO? So it's NO. When we put the NO, it will be directly balanced with the reactant side. So that's the slow. It's done. It's finished. Okay. It's NO2. It's NO2. Which one? Okay. So it says the slow step of. So it doesn't mean that this is the slow. This is the net. Then what about the slow step? Consists of a collision of two NO2. So the reactant of slow is 2NO2. Done. What is the intermediate? NO3. Where is intermediate? Product of slope. So we put it here. Now, this reaction is not finished. So you have to look at the product. So it's either NO or CO2. It's either NO or CO2. So if you put CO2, is it going to be correct? No. But if I put the NO, it's done. Then, when you want to find the fast, then just reverse the slow, add it with the net, you'll get the fast, okay? For B, it says reaction rate law. Where do we take rate law? From slow step. Again, R is equal to K, concentration of NO2 square. C, it's asking question about how does the rate change. It's asking question about how does the rate change. It says, if we double concentration of NO2, what factor reaction rate changes? So we have NO2. If I double the NO2, how would the rate change? 2 to the power of 2. So rate quadruples. Rate quadruples. After we find the rate law, it's asking, if we change concentration of NO2, how would the rate change? If we double this, what is the square? What's the power? Square. 2 to the power of 2, double to the power of 2, so the rate will change by 4 times, okay? D says, what if we change the concentration of CO? Do we have CO in the rate law? No. So, if something is not in the rate law, it's in the fast step, it means that it's not affecting the rate. So, you will say no effect on rate. Why? Because if a substance, guys, this is like a note, okay? If a substance is in fast, its order is 0. Its order is 0. Jana, did you write it down? Are you done? Okay. Guys, I told you there is a keyword. If the reaction says, if the question says one-step mechanism, we take the coefficient as order. It's not the slope. No. In here we don't have slow, we don't have fast. It's one-step mechanism. One step, that's it. Tara, the note said, just like the slow, we will take the coefficient. It doesn't mean that this is the slow. It means that just like the slow, you have to take coefficients as order. Yes, and besides, we said, if it says one-step mechanism and data is not given, again, just after this one, it says find rate law and determine the effect of this. Actually, instead of giving us data, it's asking questions on how the rate will change. So we have to take, in this case, we have to take the rate law, the orders from the coefficients. Now, then R is equal to K times X, so it's one-step mechanism. In this case, power of 1, Y is power of 2. So we use coefficient as orders. Like, I think we have 3-4 questions in the ministry. All of them contain this keyword. It says one-step mechanism. Now, done. We got the orders. We got the rate law. Then we can answer the questions about how would the rate change. So in the first one, it says, what's going to happen to the rate if we change the concentration of X only? So X is doubled. Don't look at the Y. If X is doubled, what's going to happen to rate? Also doubled. Why? Because the power of X is 1. So A, we're going to say rate doubles. B, In the B it says, what if we double the concentration of Y? Double to the power of 2, so the rate will change by 4 times, so increase by 4 times or quadruples. Rate increases by 4 times. C, using 1/3. 1/3 means 1/3, the concentration of Y. Guys, in this time, it means that the concentration will decrease. You can say it in 2 ways. You can say rate changes by 1/9 because the power is square, or you can say rate decreases by 9 times. Rate decreases by 9 times. For D, I'm going to write a new question regarding that. Again, what's going to happen to rate if X if concentration of X is doubled and concentration of Y is halved at the same time. So that's the question actually. The answer is what? Rate is by factor 2, or you can say rate is also halved. Why? This is 2. If you put, for X is double, so you're going to put 2 here. For the Y is 1/2. So 1/2 squared, 1/4 times 2 becomes 1/2 again. So the rate is halved. Okay, the rate is halved. Yes. Repeat which one? The last part. Normally, the question asks about X and Y individually, one by one. But sometimes we can change, since we know the orders, we can change both of them to see what's going to happen to rate. So we doubled the X and we 1/2 the half the Y. Pay attention, if 1/2 to the power of 2, 1/4, right? And X is double, 2. 2 times 1/4, 1/2. So the rate, finally, the final result of rate will be halved, okay? Is there anyone who hasn't written this part? Are you all done? Now, again, another question. The rate law for a single step mechanism. Again, one step. But this time, instead of the reaction, the rate law is given. And it says find the reaction. Again, so this is A. Let's say this is B. Now for A, write the balanced reaction of A and B. So power coefficient of A must be 1 because the power is 1. So A plus coefficient is 2. So 2B to become C. That's A. That's it. For B, now it's asking question. For B, we have to look at the rate law. It says, if concentration of each reactant are doubled. Now both of them are doubled at the same time. What's going to happen to the rate? 2 doubled. To the power of 2, 4. What about the A is also doubled? So the total is 8. So rate increases by 8 times. Rate increases by 8 times, okay? Rate increases by 8 times. Are you all done? Okay. Guys, pay attention to this question. It says following reaction is second order. What does that mean? Which one is 2? What is 2? The order of what? It says following reaction is second order. So it's order of what? It's actually total order. So it's the order of both NO and CO. It's both. Okay? Total. Now, the net reaction is given, and it has given us information about one of them. It says, if rate of reaction increases 4 times after doubling the concentration of NO. So it means that we have changed concentration of NO, doubled, then rate quadruple. Rate quadruple. Then what must be the order of NO? Order is 2 for NO. What about CO? It means that it's 0. Why? Because if the total is 2, so the trick is actually here. The trick is here. This is total order. If total is 2 and NO is also 2, what is left for the CO? Nothing. So this means that order of CO is 0. So if you want to write the rate law, R is equal to K times concentration of... Alright. R is equal to K times NY. Because we said order of NO is 2. Then order of CO is 0. But order of anything to the power of 0 is equal to 1. So you don't have to write it. So it's K NO squared. Now, if we know the rate law, this is the reactant of what? Reactant of slow, fast, reactant of slow. So slow is 2NO becoming. This is slow. Now, we have to look at the product. But first, what is given? Intermediate is given. What is the intermediate? N2O2. Just write N2O2. If this one is N2O2, do we need anything else in the slow? Let's balance it. How many NO? 2 NO. How many oxygen? 2. So nothing else. The slow is done. This time it's easier to find the slow. When you just write the intermediate, the slow is done. Again, it says write the reaction mechanism, reverse the slow, N2O2 becomes 2NO. So this is the slow reversed, added with the net. Added with the net. What is the net? It's NO plus CO becomes NO2 plus C. Cancel NO, NO. One of them is left, and that's it. So the first step is N2O2, CO, 1NO, 1NO2 plus C. That's the first step. Done. Okay, that's the first step. And this question, it's a homework. It's kind of difficult question. So just work with it. After that, we're gonna do something about it, okay?